Okay, we are going to talk and explain about electric fields. Well, an electric field surrounds an electric charge and exerts force on other charges in the field, attracting or repelling them. An electric field is sometimes abbreviated as an E field. Okay, so the electric field is defined mathematically as a vector field that associates to each point in space. This can be exerted on an infinitesimal positive test charge at rest at that point. It's measured by force per unit of charge. Okay, well, as its name says, it has two parts: the electric fields and the magnetic fields. The electric fields are created by differences in voltage. For example, when the voltage is higher, the resultant field is stronger. The magnetic fields are created when electric current flows. For example, the greater the current, the stronger the magnetic field. And these magnetic fields can be found in different parts, natural and human-made. In the natural electric fields, for example, it's when a compass needle orients in a north-south direction, because the Earth's magnetic field makes it do that. Also, the birds use this for orientation. And an example for human-made fields are, for example, the X-rays, the power shocks, and the radio waves.
Electric field lines. A field line is a locus that is defined by a vector field and a starting location within the field. So, for electric fields, we have electric field lines that act as a kind of or map that give the direction and indicates the strength of the electric fields at various regions of space.
A scalar form from an electric field is a vector because it has a magnitude and a direction. You can calculate it by using this formula. E is equal to F over Q. E is equal to electric field magnitude. F is electric force between two charges, and Q is test charge. By substituting Coulomb's law in the last equations, we can get formulas to calculate the electric field of a charge. E is equal to K multiplying Q over R squared, in which E is equal to electric field, K is proportionally to constant, Q is charge, and R is distance from Q to any point.
The electric field superposition principle. The electric field superposition principle states that the electric field of any charge combination is the vector sum of the fields produced by individual charges. If you want to calculate the electric field produced by a continuous charge distribution, divide the distribution in smaller elements and calculate the field vector produced by each one. Then perform the vector addition of all the components. We can express the electric superposition principle as follows. E is equal to F0 over Q0, it's equal to E1 plus E2 plus E3